So copy this down to page 5 and answer. Try to be conservative with your space when you copy, regardless of where you ended up. So a couple of things. Don't round too soon in this unit. Don't round like if you do round, double your decimals. So if you don't want to use all decimals, use 4 in the meantime. So especially when you're trying to find measurements to get your final answer, you got to watch out for that. All right, if you want full marks, if we don't care about full marks, do whatever works for you. Okay, 1A, the volume. So it's in your best interest to have the formulas for all the shapes on your study sheet. Okay, so for a cone, it's pi r squared h divided by 3, correct? All right. It's Monday after a spring break, so you better watch out. Radius is 4, so just square that, and then your height is already given. It's not slant, it's height, so you gotta watch out. Divided by 3. And if I plug that in, right, use pi, I don't know, have we used pi? It's right here, so second hat, right, that's when you call pi there, times 16 times 12, and then sure you would divide that by, so this keeps going, divided by 3, and there you go, it's 201.06, and that would be cubic inches, right, inches cubed. So that's your answer there. Clearly indicate your final answer. B, surface area. So surface area, you need your slant, right? We need the slant height. So what is that? So if you have your cone, you got to watch out. Sometimes I give you diameter, sometimes I give you the radius, right? But what we know this and we know that, we want to find our slant right there. So this is 12 and this is 4. And so to find the slant, we would just go square root of 12 squared plus 4 squared, right? Pythagorean theorem. Hypotenuse squared is leg squared and added. So this would give you a root of, I did a little bit of work already earlier, so that's 160. I would just leave it like that, root of 160. It doesn't hurt, but if you want to use decimals, that's fine. That's 12.64, and then I'll just indicate that I'm using all decimals, right? So I would give you a mark for that normally. The question would. So surface area, help me out, pi r squared for the circle at the bottom, plus pi rs, correct? Yeah, you might have a different, I may have given you a different formula, but it's just a variation. So that looks right to me. Pi r squared plus pi r, and then s goes there. We can go root of 160 or 12.64 repeated, and so that'd be 16 pi. That's 50.26 something, and then this would be 4 times root of 160 times pi, 158.95 and something. If you add everything, I'm just going to copy paste here. That's 209.55 if you round that. And now we are in squared inches squared. Okay. Are we good? Do I have a couple that got the same? Yeah, I have a bunch of nods, so I'm going to go with it. Okay. Watch out, because sometimes I give you the slant, you have to find the height. Okay, so there's not just one way to solve these, there's many ways. Okay, was there a C part? No, there wasn't. 2, the sphere has a surface area of that, determine the radius. So surface area of a sphere is 4 pi r squared, correct? Is that what you have? Okay. This is just coming off of memory. I'm hoping I get this right. So we know the surface area, so we go 1240, and this is 4 pi r squared. So however you want to do this, I'm going to go divide it by 4 pi on both sides, like that, cancels out. And to get r, I'm just going to take the root of 1240 over 4 pi. Got to be very careful how you enter this into your calculator. To be honest, I would first do, okay, you got to be careful because it's 4 times pi. So if you want to divide, you got to use brackets, or else you're not going to get the right answer. You got to go like that, 1240 divided by 4 times pi in brackets, right? And then you take the root of that. Oops. What is it that you don't like? Okay, I'm going to plug that in. There we go. 9.93. And this is in, is it feet? Square feet I gave you, right? Yeah, so this would be in feet if you want the full. And now I could ask you to find the volume using this. If I asked you, just pay attention here. If this whole question is like, what is the volume of this thing? Then you first wanted to find the radius, but don't round yet, right? And then you plug this into the volume is 4 pi r cubed over 3, right? You plug this radius into there, and you would only round once you're done that. Like, it depends on how the question is. If it's A, find the radius, and then B, find the volume, it's okay to round, and then use your rounded answer for volume, right? So keep that in mind. This was question 2. Okay, and then question 3, it asks us to convert, right? Basically they're asking what's 1240 square feet? What is that in cube and squared yards? Sorry, that's what I'm asking you to do there. And the province will not give you conversion rates, so you got to watch out. So if you want to go 1240 square feet, think of, oh, I'm going to go to yards, right? So you know that 1 foot has, no, sorry. I got this. 1 yard has 3 feet. Okay, we know that. And you can't just cancel out feet with, right? So you got to square this. So that's 1240 square feet times 1 squared yard over 9 square feet, right? Because you're squaring everything in here. And so now you can go ahead and convert. You got to make sure the square feet are at the denominator so they can cancel out. So it's basically 1240 divided by 9. 1240 divided by 9, and that's 137.78 squared yards. Okay, so that would also be something that I would expect you to know how to do. So I'm converting mainly within systems. So we're staying within the imperial, we're staying within the metric. That's basically where it's at. Okay, so if you were able to follow, you're in good shape. Let me just show you. This is every fall the province sends us a little memo, and under design and measurement, this is not everything. This is just like, hey, reminder, right? So students are expected to determine perimeter and area. It's like, that's pretty easy. But they should also say, hey, it's still surface area and volume and all of that. I don't know why they just limit it to that, but whatever. Students are expected to convert within systems, so metric to metric, imperial to imperial, with or without technology. You always have your calculators on you, so you'll be fine. And unit conversions will not be provided on the test. Note here, in design and measurement, students must buy materials and hold units. I will add that in your notes, so don't worry about it. It's in your notes. But when you buy stuff, you can't buy partial. Be it square yards of carpet, cubic yards of soil, whatever. You have to always go whole units before you do your cost. Unless the question indicates that partial units are available. So again, they will say, hey, you can actually buy partial, but if not, then we're always assuming whole units. and you're expected to be able to plan the layout. You're supposed to plan the layout of component parts for a project. So we're going to do that starting tomorrow. Hey, you're doing this project in your yard or your house, calculate the cost of renovations and whatnot, which I did already a little bit in grade 11 applied. Remember the rentals of the room? So it's just going to be maybe a little bit more, but other than that, that's what I expect you to do. Okay, so I'm going to assume you did everything up to 11, and we're going to jump into now using those formulas. So let's go to 13. Let's go to 13. All right. So here we go. Solving problems involving composite shapes, hollow shapes. Should I say truncated? I don't know if you ever heard of the word truncated. It just means cut off. Like you cut them off, chop off the top, and it's like, hey, this is what remains. Like what would be the surface area of that, right? So now that we've reviewed and derived the formulas of the most common shapes, we can use the knowledge to determine the surface area. Right, we're going to determine the surface area of more complex shapes. Important steps to include. Write down all the sides you need to include and which need to be subtracted or omitted. Okay. Write down what you're including. This is 13. And which ones need to be subtracted or omitted. Like a lot of students don't think of subtracting. Use abbreviations, include all shapes. Start to write down the formulas required. Include formulas of faces to be subtracted. If you choose to solve everything separately, this is important. Do not round too soon. Make sure to check if your answers make sense. So if you get like a really big number or a really small number, maybe double check. When multiple shapes connect, we do not include that portion that overlaps. Okay, so maybe I should give you a little. So if you have, let's do this one. This one is like a cone sideways like that, meeting a cylinder. Right? We would not include this. We would not include the circle from the cone's perspective, nor would we include the circle from the cylinder's perspective. Okay, so it's kind of like you will need to take away from both of the formulas. Well, I want to add this to, don't forget, let me first write this out to see if it makes sense. Don't forget to divide. So example, sometimes we have the surface area, or no, volume, let's go volume, sorry. It's 4 pi r cubed divided by 3. A lot of students forget to divide by 3. Like, I can tell you know exactly what needs to be done. You write it out perfectly, it's beautiful, but I can tell when I continue and follow your work, it's like, oh, you forgot to divide by 3. So watch out for that, right? So do the top, sure, hit enter, then divide by 3. Okay. And don't fall into the trap of doing everything in one shot, because that also bites you. Okay, let's put this into practice. Let's go to page 14. Let's have fun, guys. We'll have fun with this. Yeah. Okay, composite shapes. I don't have any cost yet in here. I would like to have done that, but right now we're just going to focus on finding, because the cost I can teach you, finding the surface area volume, that is a little bit trickier. A company needs to produce cardboard boxes as depicted below. Calculate the amount of cardboard needed. Okay, pay attention to this part. I'm giving you a hint, right? But cardboard needed, you should think, right? Surface area. I hope you understand that if it's cardboard or fabric used to cover something, anything that's like thin pieces to make something, that's surface area. If it's what would be the capacity of the box? I'm going to use a different color for that one. Capacity, how much would fit in? These are key words. I'm going to go arrow there and meet the other one. And this is volume. Okay, so I would say that most of the time it is quite obvious, but sometimes it is not. Right? Like they'll just say, hey, determine the amount of cardboard needed. And some students actually do volume on this one. So make sure you understand what is it that they're asking for. Okay. And I went, if it costs, and I never finished my thought. Maybe I'll add that later. But let's find out the surface area first. Let me see here. I think I was able to fit everything down here, so we'll do that. And then we'll do the volume most likely up here, because volume is usually less work. So we go here. And this is where you just have to be very careful. I will right away indicate, I will kind of put lines here indicating like, hey, that's an overlap. I should not include that. That's going to be open, right? So here's my thought process. Watch this. I'm going to start at the very left here because it's going to be a long process. Total surface area. It's going to be the surface area of the cylinder without bottom. I kind of first write out what it is that I'm planning on doing. Plus the surface area of the box. By that I mean the rectangular prism, okay? Without circle. Watch this. Without circle on top. Would that make sense to you? That I have to say, because if I use my formulas for the entire box, it's gonna determine the entire top, but I don't want that piece included in my surface area. And so when I look at it from the cylinder's perspective, I just want to omit the bottom. So both of them technically are subtracting a circle, okay? So here we go. Now I'm going to use formulas. Surface area of a cylinder. I'm going to actually do this. 2 pi r squared plus 2 pi r h. And I'm going to put square brackets around this. Kind of want that all in one there. Plus surface area of the box. That's 2 times length times width plus 2 times length times height. Sorry. Plus 2 times width times height. I'm not going to do a square bracket just yet, actually. Watch what I'm going to do here. So this is the entire box here. I'm going to go minus pi r squared. This is my pi r squared of the small. So I'm going to go minus pi r squared. There you go. And over on this side, what's wrong right now with this formula right here? I could go minus pi r squared, but that's too much work. Instead, I'm just going to get rid of this 2. Okay. Because there's I'm taking away the bottom circle. So now I'm only including one pi r squared instead of doing both pi r squares. I hope that makes sense. So how about, I'm going to try this here. You look at it and see if that makes sense. So basically this takes care of that. And without circle on top, it's this guy right here. So I've taken away the pi r squared on both, for both components, for both shapes that I'm including here. And now I'm ready to fill this in with numbers. Okay, so TSA, let's go and type this in. This is what I'm going to recommend to you here. Often there's a shape, not always, but I'm just going to say radius is half of that. So it's 1.5 inches. It's nice to just know, okay, that's what I'm going to use for radius. Everything else is okay to stay as is. So I'm going to go pi 1.5 squared plus 2 pi r times height, which is 20 inches, the height of the cylinder. I'm going to still keep my square brackets. I don't know, for me that helps. So that would be the cylinder. Are we good there? Am I going too fast? Slow down. You're good? Okay. 2. And now a lot of students get this part. It's like, which one is length, which one is width, which one is height? In this case, it doesn't really matter. But generally, we go length, width, and then height like that. So I'm just going to label it to not mix things up. So this will be 10 times 6 plus 2, 10 times 4 plus 2, 6 times 4 minus pi r squared. Close this thing. Now, the square brackets don't really need to be there. I just like to chunk it off. Anybody notice these two here? You see what's going to happen to those? If you add pi r squared and subtract pi r squared, they technically cancel out. If you miss it completely, you're going to be all right. Like if you just like, no, I'm just going to do whatever I have on here. I'm going to type into my calculator. I'm going to get it. Go for it. I'm going to pretend like I'm not seeing it. Okay? So that's how I'm going to approach this. You can go ahead and cancel those out. But here we go. Because it doesn't always happen. So pi times 1.5 squared plus 2 times pi times 1.5 times 20. So this you can actually do in one shot if you'd like. Okay, so that's 195.56 dot plus, I'm going to figure out what the other side is. If it's kind of like a linear thing where there's nothing being divided, you go ahead and type this in all in one shot. So it's 2 times 10 times 6 plus 2 times 10 times 4 plus 2 times 6 times 4 minus pi times 1.5 squared. So I typed it all in one shot. See if you can get the same. That's 240, 931. Don't round just yet. Dot. And because I want to be conservative with my space, I'm just going to add these two and get the total right here. So my calculator has that all saved. So I'm going to go enter plus copy paste. So it's 436.50. 495, right? So now we can round to 2 decimals. And we are in inches, so this would be square inches. This would be cardboard required. If we needed to find out the cost, we would not, like if we have to pay per square inch of cardboard, we would round this up or down. The province is okay with you doing either. I would automatically go up. That's just what I would do. So stick with the rounding that we taught you all along up until this point, and you'll be fine. Okay, so this is the cardboard. Cardboard required. Same if we ask for fabric, same if anything that you use to make something or cover something or paint, that's always squared, that's square footage, right? Surface area. Okay, let's cut this here. I'm quite confident that we can do the volume. Volume is usually easier because with volume, you don't need to worry about overlapping faces. Okay, so that's usually, don't quote me on it, okay? Total volume, it will just be the volume of the cylinder, and you can use whatever abbreviation you would like. I'm not picky with that. Plus volume of box. TV, volume of the cylinder, that's pi r squared h plus volume of the box would just be length times width times height. That's just all that there's to it. So let's plug in values. Pi r squared times 20 plus 10 times 6 times 4. You want to plug that in to practice. Pi. Don't just use 3.14 for pi. That's not good enough. Okay, like you got to use up more than that. Plus 10 times 6 times 4. I just happened to enter everything in one shot. You could have done it in pieces. And so this is cubic inches. Okay, this is my total volume. This is the capacity. We talk about capacity if it's a hollow object you can fill. We talk about volume normally if it's solid. But really they mean the same thing. Right? One is if it's a solid, it's already filled in. In this case, it's hollow, so we can fill it in with that much. So keep that in mind. Okay. What are we at time-wise? I'm gonna stop here, and I have a few questions that I would like you to try though. Where are we here? Okay, pages 19 to 21 have questions that are good. So here you go. Can you write this down, homework? I'm actually going to go pages 19 to 22, and I would really recommend you do all of them, but if you run out of time, I would say questions 1, let me just scan here, 1, 3, 4, 6, and 7. Yeah, try those and see how that goes. I will post the key to the entire thing. So if you need to see, and they're detailed. It's not just the answer. So then you can tell if you're doing it right. Trust me, it's worth your time. Okay, so practice that.